Welcome back. Today we're going to start making some noise. In particular, we're going to do some bandpass filtered noise. In this video, we'll create a simple sound source, and in future videos we'll implement a control signal to control wind speed, add layers to the effect to create more depth, and create additional effects such as howling and whistling. In this video, I'm going to create a JUCE XCode project, add it to Github, code a simple bandpass filtered sound source. This is going to be really useful to create a wind effect. We'll test that sound source and we'll create a blank Unity project and add the plugin. And then I'll demo the plugin in Unity. So that's what we're going to be doing today. The first thing we need to do is to open a JUCE project. So open a new project. That's File, New Project. And they'll come up and give you the GUI option. We're not interested in a GUI. What we need to do is to select the basic plugin, which is on the left-hand side, halfway down. So we select that. Next, we have to add the DSP modules. We're going to be using proper DSP code, so we need to add the DSP module. So on the right-hand side, you can expand and scroll down the modules list and tick on JUCE DSP. Next, I'm going to name the project. So you can see at the top, I'm going to call it Win for Unity 1, and then bottom right, Create Project. This will open up the Save Project window. Just select the directory you want to save your project in, and then bottom right, click Open. And as if by magic, you now have the start of a JUCE project. Now this project has 4 components to it, 4 files. The plugin editor CPP and the plugin editor H we're not going to use because we're going to use a generic editor. The reason for that is that when you have a Unity plugin, if you use the generic editor, it will put all the sliders that you need within the Unity project, and you can expose the variables and do fancy things with it. If you create your own custom editor, life's a little bit more difficult, and we want to make life simple. So what we do is we select those bottom 2 files, right-click, hit delete, and then you'll come up with this window, and also move files to trash. We'll select that. So all we've got left now is the plugin processor CPP and the plugin processor H, and all of our DSP code will be contained within those 2 files. At the top, you'll see a cogwheel next to your project name. If you press on that, we'll change the project settings. So if you scroll down, you'll find plugin formats. At the moment, it's defaults to VST3, AU, and Standalone. As you can see, it's very much geared towards DAWs. But what we need is Standalone. We'll be using the Standalone to test before we actually load the plugin to Unity, and the Unity option. So we just need those 2 clicked. What we then do, on the top right-hand side, you'll see a funny little symbol. This will save the file and open the IDE. So press on that button, and as if by magic, eventually, XCode will open. Now you can see there's lots of stuff on the left-hand side here which we're not really interested in. It's all the JUCE modules and all the library code. So what I do is we're just going to simplify the look of that, close most of it down and just open the source. And as you can see, there's our plugin processor.cpp and our plugin processor.h. Now the first thing we'll do is we'll select the CPP file. Now we've got an error here. This is because we deleted the editor files, and obviously we've got an include to the plugin editor.h that we deleted. So we'll delete that line. We don't need it anymore. So that's nice and clear. Just below that, you'll see the constructor. And the constructor initialization is a little bit complicated, and this is for a plugin, so it has inputs and outputs. We simply want the output. So we're going to get rid of all of the orange stuff, the hash in endef and hash endif and all of that stuff. And we'll just be left with the .with output. We're not interested in the input. So we'll delete the whole chunk here, and that's what we want to be left with. Next we find the method create editor. This will be a fair way down the CPP file. But if you find that, what you'll see is that we've got return new Win for Unity 1 audio processor editor. Now that's the thing we deleted. So what we want to do is to change that bit that's causing the error to the generic editor. So we replace that with JUCE, generic audio processor editor. Simple as that. Now you'll see JUCE namespace is used a lot here. It's advisable to type it in every time because there can be conflicts, and they tend to recommend that you don't do namespace using JUCE. So you'll see a lot of JUCE : It basically just means that's the namespace that this function exists in. Next, go down to the process block. It's a little bit further down. And you'll notice in there there's lots of comments. We're going to get rid of most of this. Near the top, you've got total num input channels and total num output channels. What I'm going to do is comment those out. Now, the quick way in XCode to comment them is to select them, Command \. So we'll do that, and we'll comment those out. We'll keep them there because we may need them later, but at the moment we don't need them. Next, we'll add a buffer.clear. Now what we're doing here is we are making sure there's no junk data in the buffer. This is the audio buffer. The process block is where the buffer is processed every frame, so it's where your frame is constructed. So we make sure there's nothing in it, buffer.clear. Next, we want to get rid of just about everything else below that because we're going to be doing everything slightly differently. So select everything down to the curly brackets that end the function and delete. So we're left with a very clean process block. We'll be filling it up a little bit, but there won't be much in there. Next, we go back to the header file. So plugin processor.h. We go down to the private section, and this is where we're going to do our declarations.
We will create 3 private methods. The first is DST_prepare, which will be called by the prepare to play method when JUCE starts the plugin. Next, there will be DST_process. This will be called by the process block and is where our DSP code will sit. Finally, there's DST_update settings. This will be called by the process block again. This will update the various sliders every time the block is called to update things like the cutoff and the resonance.
DST, distant, distant wind, distant prepare, distant process, distant update settings. So next we actually start defining our parameters. So here we need to define some pointers. We've got JUCE audio parameter float star pointer gain. So that's going to be our master gain. That's our first parameter. Now what these are pointers to the parameters that actually exist in the GUI. Now the GUI is running on a separate thread, and what we do is we just create a pointer to that, and we'll load that at some other point in a thread-safe way. So first of all, what we do is we declare these pointers. We'll initialize them next. So we have a gain pointer, and then we have a DST bandpass cutoff frequency. Then we have a DST BPQ, so some resonance, and then some amplitude, DST amplitude. The DST amplitude is there to adjust for where the bandpass filter is losing some of the gain. So it's just a little tweaky thing. Next, we start looking at our DSP resources. Now, as I say, we're going to create some noise, and then we're going to filter the noise. So the first thing we declare here is the oscillator, which is the noise. Now here's where we start getting into more fancy stuff. We've got a lambda. And what we do here, we declare JUCE DSP oscillator. Now this is a template, so it's a float. And that's what the greater than equals to brackets are doing. That's the templating. So that's creating an oscillator which is feeding out floats. And we're going to call that DST noise 1. And then the next line down, you've got the curly brackets, 2 square brackets, float x. Now float x is really what's being returned here, but the rest of it and the curly brace semicolon at the bottom, that's just how a lambda is defined. So you just have to remember that's how it's done. And then within the curly brackets, within that, we've got JUCE random R. Now, what we're doing there is we're declaring a random number generator. And then next, we're returning r.nextFloat. So we're returning a float. The float's between 0 and 1. So we multiply it by 2, take away 1, and that will give us a float between -1 and +1, which is what we want to do. So next down, we'll declare the state variable filter. So we've got JUCE DSP state variable filter TPT filter. Now, TPT filter is quite specific. This is a template function, so we declare it as a float. All of our samples are floats, so we declare them as floats. The TPT filter is a very well-behaved filter. And when you sweep a filter, sometimes what happens is you will get anomalies occurring. You get very loud spikes and peaks occurring if you sweep too fast. The TPT filter keeps the filter well behaved and stops that happening. So it's a nice filter. It's a proper state variable filter. So we'll do low pass, band pass, high pass with resonance, and we'll call that DST BPF. As you can see, everything is DST. Okay, so go back to the CPP file, up to the top and to the constructor. Now what we need to do here is, as I said, we declared some pointers to audio parameters. What we've got to do now is we've got to initialize them. We have to do that within the constructor. So what we're doing is we're using the method add parameter. So the first one we're going to do is the gain. So we have add parameter, open brackets, gain equals new JUCE double colon, and then you start typing audio parameter. And as you start typing, it will auto-fill, and this should come up. Now the one we want to pick is this one. It's the one where it's got string parameter ID, string parameter name, minimum value, maximum value, and the default value is the other one that's gone off the screen. Okay, so we've selected that. And as you can see, we have 1, 2, 3, 4, 5 values, 5 parameters we've got to add. The first string parameter ID is not something we're going to use, so it doesn't really matter. You can type whatever you like in there. This is used within JUCE to identify the actual parameter in some code, but we're not going to be using that sort of code at the moment, so it really doesn't matter. The second string, the string parameter name, is more important because that's the string that Unity will display next to the slider. I think you've got 14 characters to play with, but that's the important one. Then after that, quite simple, minimum value, maximum value, default value as floats, because it's an audio parameter float. So that's how we're going to code the gain. So we're going to call it master gain. In both of the strings, we're going to call master gain. Got a minimum of 1, sorry, a minimum of 0, a maximum of 1, and we'll set the default value to be 0.5. Then we fill in the other 3. It's all much the same. So we'll add parameter DST BP cutoff frec, and we'll create a new JUCE audio parameter float, DST cough, just made it short. What I'm going to call this one is distant intensity. As you see, I had to shorten it. And what we're going to have is a minimum value of 0.004 as a float. Now, you don't really want your cutoff to go down to 0, so I've chosen something that's nearly 0. We'll then have a maximum value of 1000. Now, this gives you a nice whooshy, wind, whistly sound, high-pitched. And it ranges from quite a low rumble all the way up to quite a nice sort of shh sound. And our default will be 10, so we'll have it quite low. And then we have the DST BPQ, which is the resonance. We're going to call that distant Q. The minimum there, we're going to select 1, maximum 100, which is probably a little high, and we'll have a default value of 10. And then finally, we've got DST amplitude. We'll have that as a JUCE audio parameter float. We'll call that distant amplitude. And the minimum here is 0.0001. Now you're going to ask me, why haven't I chosen 0? This is where we get into denormalized floats. Because there is a danger you could create a denormalized float here if you went down to very nearly 0. And the issue is that, particularly with filters and things like that, you've got to be a little bit careful, because if the processor gets to the point where it's trying to process a value between the smallest float value it can find and 0, then the CPU will go crazy. Your CPU usage will go up something like 30, 40, 50, 100 times. It's ludicrous. And unless you've done DSP programming, you won't believe it. But actually, when a filter's doing nothing, it's very bad. Next, we have the maximum value. Now, this is a gain adjuster, so it's going to be above 1. As I said, the bandpass filter will tend to attenuate a little bit, so we'll allow that to go to 1.5. And we'll start off our default value as 0.75. Okay, next we go to prepare to play. As I said, at the start when JUCE runs, it will prepare all of its DSP code. And what it will do is call this prepare to play. It's a little bit down in the code, but you'll find it eventually. And what we do here, the first thing we do is we create a spec. If you remember when we created the private method, it was passing a spec in, a JUCE DSP process box spec. And that's what this is. And what this is, we fill it with the necessary data. So the spec has a maximum block size, and that equals the samples per block. As you can see, that is being fed in when prepare to play opens. With Unity, you can actually set the frame size or the block size. You can either have 512, 1024 or 2048. And that's where this is being picked up. So it picks this up and we will pass this into our spec. So spec.maximum block size equals samples per block. Next, we want to know how many output channels there are. So the spec.numChannels equals get total num channels. That's a method that's available. And then spec sample rate equals sample rate. Sample rate is being brought in as a double into prepare to play. Again, it depends on the sample rate of your platform. So this is a variable that's passed in here. What we then do is we then pass this information to our DST prepare. So our prepare distant wind. Now, if you remember, if we go back over to the plugin processor header file, in the private section, we've got DST prepare, const JUCE DSP process block reference spec. Let's go into this a little bit more. What we've got, const, we're not going to change it. It's just been passed in as information. And the process spec is a JUCE :DSP : process spec, and the ampersand is a reference. We're not going to take a copy in, we're just going to take a reference to that spec, that specification. So what we're going to do is we're going to define all of these functions. We can right click, generate missing function definitions, and off we go. Now, whenever I do it in XCode, it always tells you I can't do it because I'm indexing, so you have to do it twice, which is slightly annoying, and I've never found a way out, but that's life. What we'll also do while we're here is we'll generate the function definitions for the DST process and DST update settings as well. And then when we go back to the CPP file, we'll find that actually these have now been neatly created for us. So right down at the bottom of the CPP file. So if we go to DST prepare, which is being called from prepare to play, the first thing we'll do is we need to prepare the noise source. So what we do is we pass the spec into the DST noise 1.prepare. So there we go, DST noise 1.prepare, pass in the spec. Then next we need to sort out the filter. So much the same way, our DST BPF is the definition of our bandpass filter. Actually, we haven't called it a bandpass filter yet. That comes next. And we prepare spec. So we're passing in the channels, block size, and sample rate. Next, we set the type. As I said before, now we haven't actually said this is a bandpass filter, and this is done simply by dst-bpf.setType. Then we've got JUCE, dsp, state variable tpt filter type, bandpass. Now here's where you could select low pass or high pass. Now next we initialize the cutoff frequency, so dst-bpf.set cutoff frequency, and here we're getting the value of the most recent slider position. So dst-bp cutoff rec is our audio parameter. Now this is sitting, as I say, in the GUI or in the game thread. So we have to get it safely. So we use the arrow operator because it's a pointer, and we use the function get, which is an atomic get. It's not just reading it, it's making sure it's not being written to at the same time. So because this is on a multi-threaded system, you have to be careful, and you have to use this special method to go and get the data. And the same with the resonance, so dst-bpf.set resonance, and then we've got dst-bpq arrow operator get again, so we're getting it safely. And then the final thing we do, everyone does this, dst-bpf.reset. Once you set all of that, it's good practice to reset the filter. Okay, back to the process block. As you say, it's quite clear at the moment, but we'll add 3 lines to it. The DST update settings. As I say, what this is doing, this is every frame updating the various sliders and putting it into our audio. So we'll update the settings every time we run through process block, so every frame. Then we'll process the buffer, DST process pass across the buffer. And then finally we'll apply a master gain, so buffer.apply gain. And again we do this atomic safe gain arrow operator get. So the gain slider information for the gain will be applied to the whole buffer. So if we go down to the bottom now, we go to our DST process and our DST update settings. First of all, we can update our settings. As I say, what we're doing here is we're setting the cutoff frequency again and setting the resonance. We're just getting the current value every time we run round the loop, the frame. Every time we're doing a processing a block, we'll check to see if there's a new value there, and we do it thread safe. So we use the get function. And then we go into the DST process. Now this is actually the audio side of things. This is actually our DSP. So the first thing we'll do in this is we'll get some buffer information. So we'll get the number of samples, which is directly from the buffer. So buffer.getNumSamples. And we want num channels. So we want buffer.getNumChannels. And then we need the amplitude, which again is one of these audio parameters. So we've got DST frame amp. We're going to call it the frame amplitude. And that equals DST amplitude arrow operator get again, thread safe. And now we have our win DSP loop. So first of all, we'll wrap round the channels. So for int channel ch equals 0 to ch less than num channels. So if we've got 2 channels, it'll go 0 to 1. And then we increment channels. So simple for loop. And then within that, we'll then go through the frame, each sample of the frame. So for int s equals 0, from sample 0 to s less than num samples, so the size of the frame, and we'll increment that by s, the sample. So we'll increment through each sample on each channel. And what we do is we create an output, a float, because we're dealing in floats here. All of our buffers are floats. So what we do is, if you look at the way I've written this, the last thing that happens is always the first thing you see. So the last thing that happens is we process the bandpass filter. So DST-bpf equals process sample. And then inside, what we pass in is the channel, or ch, because the filters are by channel. Remember, we've told it how many channels there are. And what we're passing in is DST noise1.processSample. So we're processing a sample, getting a piece of noise, getting a sample of noise. And a slightly weird thing about JUCE is it allows you to pass in a float. What it will do is add to that float. So normally we just pass in 0.0 because we're just creating something. So that's how we're doing it. We create the noise inside the bandpass filter. And then what we have to do is to take that output. So we have buffer.addSample, select our channel, select our sample number, and then we have the output that we've just created times the frame amplitude, DST frame amp. And that's all there is to it. So what we're doing is for each channel and for each sample within the frame on that channel, we're adding a filtered bandpass filtered bit of noise. Okay, what we'll do now is we'll test it. So up the top here, we'll change into the standalone plugin. And then we go to Product, Scheme, Edit Scheme, and here we're going to make sure that we're in debug. You usually are. The default is debug, and then hit close. Top left, we hit run, compile and run. And that's what you should get. This is our standalone app. What we'll do is we'll move the queue down to 1 and then do a gentle sweep of the filter. As you can see, this creates a nice distant wind sound. We'll now increase the queue a little and do the same sweep. Now we've got more of a whistle effect. Okay, so now we've got it working, what we need to do is to sort out the Unity plugin. So up the top here, we'll select the Unity plugin. And then we're going to Product again, Scheme, Edit Scheme. Now this time we don't want to debug because it produces a huge, great file. So we'll actually make that release. So you will need to change that. Change that to release. Make sure it's the Unity plugin and then hit close. And what we can do then is top left again. So compile. Okay, I promised you GitHub. So what we've done now, we've created 2 executables. We've created the Unity library as if by magic, completely invisible, can't run it, not yet. And the standalone editor. So what we're going to do is if we open up GitHub Desktop, that's what I use. Top left, you've got a little down arrow. If you press on that, you can add. So we press on add. And that will come up with 3 options, and we want create new repository. And this window will appear, so we'll need to pass in our name, which is actually the project name. It has to be the project name, otherwise it won't pick it up. And a little description, and then hit choose. Now choose, what we do is we go to the directory that project sits in. You don't go into the project, the individual project directory. As you can see, we're at the code level, not the Win for Unity level. Then press open. What we then need to do is to create a git ignore file. We can't use, there's no defaults in GitHub for JUCE, so we're going to have to make our own. It's quite simple, just in a text editor. We'll get rid of the builds file. These are all the intermediate files. You don't want those, all the object files. We don't want the JUCE library code. You saw there's tons of it. We'll exclude that. And we don't want the .ds_store, which is an operating system directory. It's usually hidden, so you never see it. But it's done for indexing the directory and various things. So they are the three things we ignore. So what we do is we copy that into the project directory. So that would actually be in the Win4Unity1 directory. Now it's a hidden file. So if you want to see hidden files, it's Shift, Command, full stop, and that will make them visible. And basically you just copy that into that Win4Unity1 file. What we then do, I'll initialize it with README. We say none, forget, ignore because we put our own one in. And I use the new GPL v3 license. The reason for that is JUCE asks you to do that for their projects. It's one of the things, if you want to make your JUCE projects open source, they do require new GPL v3. And then we hit create repository. That should go away and do its business. And then we got publish repository. So this is actually the first step was to create the private repository. And now we want to publish the public one. And what I've done here, if we click on the publish repository, I've kept this code private. I've unclicked because I don't want to keep it private. I want you guys to be able to see it. And then I hit publish repository and bingo, it's done. Next, Unity. Okay, we're on the final stretch now. So let's open Unity Hub and create a new project. We'll just select a simple 2D project. We'll call it Win4Unity, and I will put it in my Unity projects directory. Then bottom right, hit create. Then after a little while, you should see this, which is the blank Unity project. What we want to do is to create a folder, which is the plugins folder where the plugins exist. So create a new folder called plugins. It's important it's called plugins, capital P, because that's the way Unity knows where it is. What we then do is we go back to our project, our XCode project, and if you look down in builds, Mac OS X in my case, and go to release, you'll see there's an audio plugin underscore Win4Unity1 bundle. Now what we do is we drag that into the plugins folder. So there it is in the plugins folder. Now this creates a couple of errors. This is all to do with M1 and naming conventions. The error's there, but Unity seems to sort it out, so don't worry about it too much. Next, we want to create an audio mixer, so create audio mixer. And we'll call this main mixer. Now on the right hand side, you'll see audio mixer suspend ticked. We don't want that ticked, so we untick that. And then we open up, double click on the main mixer, and there's our main mixer. Now what we'll do is we'll create a group called wind, and that will appear. And then we need to add our plugin. So if you hit add down the bottom, you'll see down the bottom, as if by magic, audio plugin underscore Win4Unity1 exists. Now, unfortunately, all of the plugins that you develop in JUCE will all be prefixed audio plugin underscore. I haven't found a way around that, but it's the way it is. It's just what you'll have to put up with, unfortunately. There probably is a way around it. I haven't found it yet. And then if you look on the right hand side, you'll see already the sliders. We've got master gain, we've got distant intensity, distant Q, distant amplitude, all the things that we did. The slightly weird thing is that the range of the sliders is always 0 to 1 on Unity. It doesn't matter if it's a float audio parameter or even it's a bool audio parameter. It'll run from 0 to 1. 0 being false, 1 being true, but we'll see that later. So now we hit run, middle top, and here it goes. Obviously we need to hit edit and play mode so we can actually change the sliders. And here we have it working in Unity. And that's it. That's how it works. In the next video, I'm going to look at how we control wind speed. This gets a little bit more interesting as we'll create functions within our plugin which control wind speed. And what we'll do is we'll expose some useful variables to Unity. So actually we'll hide things like distant intensity and the resonance, the Q and the amplitude. And what we'll say is speed, depth of speed change, and we'll create some random effects. We'll get the wind speed to change gently, we'll smooth the changes, and we'll have a really nice way of controlling wind speed. So that's in the next video, so I hope to see you then.